Hi, welcome back. We are going to dive right into section 7.1, solving trigonometric equations. Now, this section doesn't really introduce any new identities. It just makes use of the old identities and gives us a few techniques for solving trigonometric equations. So let's start with this equation we've got here. 2 sine squared t plus sine t equals 0. Now, if this were 2x squared plus x equals 0, we would know what to do. We'd factor out the x. We'd use the zero factor property. Yes? We're going to use that same technique with our trigonometric equation. We just need to realize that instead of x's, we've got sines. So I'm going to factor out the number that is sine t. And realize that means that sine t equals 0, or 2 sine t plus 1 equals 0, which means that sine t equals negative 1/2. All right, now we know that sine equals 0 at 0 and pi. So my first equation here tells me that t equals 0 and pi. And sine equals negative 1/2 at 11 pi over 6 and 7 pi over 6. So my total solution would be t equals 0, pi, 7 pi over 6, and 11 pi over 6. So I didn't do anything really new there. I just used factoring, actually. I didn't even use any identities. All right, so now let's try this again. Let's try 3 secant squared minus 5 secant minus 2 equals 0. Now again, this would factor if I were using, so let's make a u substitution. Let's let u equal secant t. So my equation now becomes 3u squared minus 5u minus 2 equals 0. We'll factor that as 3u plus 1 times u minus 2 equals 0, which means u equals negative 1/3, or u equals 2, which means, remember that u is secant t equals negative 1/3, or secant equals 2. Now my brain works better in sines and cosines, so I'm going to turn this into 1 over cosine t equals negative 1/3, or 1 over cosine t equals 2, which means then that cosine t equals negative 3, or cosine t equals 1/2. Okay, this one is impossible, so I'm going to toss it out, because remember that the pure unadulterated cosine, impossible, that's okay, is bounded by negative 1 and 1. So my solutions happen where cosine equals 1/2, which is at pi over 3. And at 5 pi over 3. again, no real identities other than just the definition of secant as 1 over cosine. And we used our factoring skills to solve the polynomial equation. Okay, things are going to get a little bit more interesting here because I've got both a sine squared and a cosine. And I think I'm going to tackle this one in the next video.